Good day. This video is the first in a series to explain how exactly you should number and write organic compounds. This video is specially made for use with the NCS curriculum, so only the functional groups and the homologous series that are used in the NCS and CAPS document will be addressed in this series of videos. What are organic compounds all about? Mostly, organic compounds are compounds made up of carbons and hydrogens and carbon chains, with a few other elements as well, but we will get to that. In this course, you will learn exactly how to write down the formulas for these compounds and to name them. And this can be quite tricky, but don't despair. If you patiently work with me, we'll see that step by step we'll solve this problem. The first thing that is very important to know is that inside a compound like this, a carbon atom can only have 4 bonds. It can only have 4 and must have 4, as illustrated in this compound over here. Can you see around each carbon atom, you will find 4 bonds every time. It doesn't always look like this. At times you can have triple and double bonds between your carbons as well. Let's look at this example. Around the carbon, 1, 2, 3, 4. But can you see in this case we have a double bond? Or we could have a triple bond, as illustrated over here. 1, 2, 3, and another one there. Okay, the next type of bond that we can have is if we have something like an oxygen that is also bonded to the carbon. Still it remains 1, 2, 3, 4, but the oxygen has a double bond. Every carbon is still connected to 4 others. In our organic compounds, every hydrogen will only have 1 bond, and every oxygen must have 2 bonds. This oxygen over here you see has a double bond, and with this oxygen over here we have 1 bond to this side and 1 bond to the other. Okay, so let's get cracking and this problem of naming them. The important thing with any problem is just to start from one point and figuring it out. What makes this problem spectacular is the fact that we are going to figure it out from the back and move to the front. So we're first going to start out with the last part of the name, which is our functional group or homologous series. Now, what does that mean? A homologous series, as defined with a CAPS document, is a series of organic compounds that can be described by the same general formula, or in which one member differs from the next group with an CH2. Now, what does that mean for you? Actually, it just means organic compounds can be grouped into different groups. And they have specific names and they can be identified with a specific formula. And we'll carefully go through each of these. What are these groups all about? We get alkanes, alkenes, alkynes. Maybe the most well-known one is the alcohols. Many of you have heard of alcohols before. That is a type of organic compounds. We will slowly work our way through each of these and explain exactly what they mean. So by now we've said that our organic compounds can be divided into different groups, and each of them are characterized by a specific way in which the carbons combine. Let's look at the first one. The alkanes, we find that between the carbons there's only single bonds. Actually, this is not truly a functional group. Just a way to identify it. So we don't really call the single bonds a functional group because they appear in all the different organic compounds that we have. So although it's written here as a functional group, technically speaking, the alkanes does not have a functional group, only single bonds, and it will always end with ane. Examples of this include methane, propane, pentane, butane, but we'll get to that later. Alkenes are characterized by the fact that they have a double bond between 2 C's. In the exams, if you are asked to write down the functional group, then this is what you're supposed to write. And they always end in ene. Butene, ethene, propene, all of these are examples of alkenes. Do not worry too much about the first part of the name. We'll slowly get to that. Concentrate from the back. We'll work our way to the front. The last group that we get is the alkynes. Ethine, methine, butine, and all of them end in Y-N-E. Okay, now just to make this a bit more clear, let's look at specific examples. Here we have our alkanes. Can you see that between the carbons we only have single bonds? Here is one example, and there's another example. If we look at their names, this one is named propane. At this stage we only focus on the last part. We'll get to the first later. This one is called 2-methyl-butane. Don't worry too much about how we get there. The important thing is it ends in ane. That's what we need to identify right now. Our second type of bonds that we have is the alkenes. They are characterized by a double bond. This one over here has got the name of but-2-ene, ending in ene, or sorry, my fault, pent-2-ene, but we'll get to that first part later. And then our last group is the alkynes, characterized by the triple bond, like this one over here, which is called propyne. Okay, that is enough of a lot of information on the first take. Why don't you quickly look at this quiz and see if you understand exactly what's going on. As soon as you get all these questions right, then you know you are ready to proceed to the next video.